Welcome to Algebra 1, Semester 1, Unit 4.5, Section 7.5. This is solving special types of linear systems. Show graphically that this linear system has no solutions. Okay, so we want to show this graphically. That means you're all most comfortable with graphing by y equals mx plus b form, which is our slope-intercept form, and it's a good form. So let's get the y by itself. So we have 3x plus 2y equals 10. We subtract 3x from each side. We get 2y equals negative 3x plus 10. Divide everything by 2, and we get y equals negative 3/2 x plus 5. Okay, so to come over and graph that, the 5 is your y-intercept. So we go 1, 2, 3, 4, 5, put a dot. We rise 3 and run 2 to the left. So approximate where that would be. We go up 1, 2, 3, 2 to the left would be about right there. Now when we get our ruler, and we go to draw that, as we lay the ruler down, we notice, well, this actually lines up with if we had gone down 3 and gone 2 to the right. So make sure that your approximation's real close. I do not want you going down to count it initially. Always rise and then run left if it's negative, run right if it's positive. I have students get the slope backwards when they start falling instead of rising, so always rise. Okay, the other line. We have 3x plus 2y equals 2. We need to get the y by itself to graph. So we subtract 3x from each side, and we get 2y equals negative 3x plus 2. Okay, now we divide by 2, divide by 2, divide by 2. So y equals negative 3/2 x plus 1. So our y-intercept this time is a positive 1. We plot that. From there we rise 3, 1, 2, 3, and we run 2 to the left. Now, you notice that it said these two lines have no solution. So my guess is you're trying to do your best to make these look parallel. I did pretty well. Not perfect, but well enough. Okay, now it says, go back and show algebraically that the system has no solution. Okay, so if we show it algebraically, the easiest way would be with our system how it's given, to multiply one of these equations to cancel the variables. So I'll take the top one and multiply it by a negative 1. So it becomes negative 3x minus 2y equals negative 10. I bring down the other equation just as it is, 3x plus 2y equals 2. The reason I did that is to make these opposites so that they'd cancel. Negative 3x and a positive 3x cancel each other. Negative 2y and a positive 2y equals 0. So everything on this side equaled 0. Negative 10 and a positive 2 would be a negative 8, and that shows no solution. Okay? Last page of the notes. Graphically, this is going to show infinitely many solutions, and then they want us to show it algebraically. So let's go ahead and graph the first one that's in mx plus b form. We have a y-intercept of 2. we have a slope of 1/2. So from that, we're rising 1 and running 2 to the right. And we go ahead and plot our line with that. Okay. Now we get the y alone for this line. X minus 2y equals -4. We subtract x from each side. We get -2y equals -x minus 4. Divide by -2. And we get y equals 1/2 x. The negative and negative wiped out, and there was a 1 by the x. So that's 1/2 x. -2 goes into -4, +2 times. So we can see they're the same line. Just put another arrowhead on the graph to show that we got the same line. So graphically we've shown infinitely many. Now we show it algebraically. Algebraically, it would probably be easiest, since the y is alone, to plug that in for substitution. So we have x minus 2 times 1/2 x plus 2 equals -4. Okay, we distribute here. We get x 2 times 1/2, 2 halves make a whole, so it's negative, because it was a -2, -x. -2 times 2 is -4 equals -4. Now, x minus x, they'll wipe each other out, and we have -4 equals -4, which tells us infinitely many solutions. Okay. Now go back, we already went back and showed that algebraically. So now we just want to mention a couple things here. Seeing the patterns in this, if we look at how we graph these, y equals mx plus b. No solutions, remember, those are parallel. Their slopes are the same. But their y-intercepts have to be different. If they weren't different, they'd be the exact same line. So down here on infinitely many solutions, we know the slope is the same and the y-intercept is the same. For one solution, the slopes will be different. And it doesn't matter what the y-intercepts are. They can be the same or they can be different. Okay? We'll see you tomorrow in class. Nice job. End of this unit. Get ready for the test.